Everyone, this is Sambaraj, aptitude trainer, Institute of Aeronautical Engineering College. Today we are going to discuss about time, distance and speed. Yes, first we know the concept of the topic. If you know the concept, then 50% of the problem solution completed. A important thing only, the relation between time, distance and speed and their applications. Here time, distance and speed method, time is equal to distance by speed. This complete topic depends only three terms. One is time, distance and speed. A general formula, time is equal to distance by speed. And their applications. Application means when distance is constant, when time is constant, when speed is constant. A second application, when time is constant, the relation between distance and speed, a d1 by s1 is equal to d2 by s2 when time is constant. And next third notation, when speed is constant, the relation between distance and time d1 by t1 is equal to d2 by t2. Similarly, when distance is constant, the relation between S1 speed and time S1 T1 is equal to S2 T2. First general formula, time is equal to distance by speed and their applications, second one, third one, fourth one. Either using direct application or using inverse application. Here fourth one, inverse application, when distance is constant, the relation between speed and time S1 T1 is equal to S2 T2. Here next, problems in time, distance and speed. But all the topics in time, distance and speed using only one method, time is equal to distance by speed. Here first subtopic, time, distance and speed, that is called basics. Here basic problems are using only direct method, time is equal to distance by speed. Second method, calculate average speed. Third subtopic, calculate problems on trains concept. When train crosses a single object, when train crosses a stationary object. And fourth concept, boat and stream. But method is same. Time is equal to distance by speed. But boat and stream topic, speed either calculate speed of a downstream or speed of a upstream. These are called subtopics in time, distance and speed. In all the subtopics are using only one method, time is equal to distance by speed. Next, here problems in time, distance and speed. Here first example, a man is walking at a speed of 10 km per hour. After every kilometer, he takes rest for 5 minutes. How much time will be taken to cover a distance of 5 kilometers? Option A, 40 minutes. B, 50 minutes, C, 60 minutes, D, 70 minutes. A logical problem, but using time, distance and speed application. Your method is very simple. By using first statement, a man is walking at a speed of 10 km per hour. His speed is equal to 10 km per hour. That means 1 hour distance is equal to 10 kilometers. Second statement, after every kilometer, he takes rest for 5 minutes. But total distance 5 kilometers, calculate. Total time with stoppages, without stoppages, that is your answer. Here by using first statement, speed is 10 km per hour, 1 hour distance is equal to 10 kilometers. Then 5 kilometers time is equal to half an hour. Half an hour is equal to 30 minutes. This 30 minutes without stoppages is taken time is equal to 30 minutes. But given problem, calculate rest time also. A total 5 kilometers, Every kilometer it takes rest for 5 minutes. Therefore, total rest time here 4 into 5 is equal to 20 minutes. But no need to calculate 50 kilometer. That point is called destination point or end point. You have to calculate only up to 4 kilometers. Each kilometer 5 minutes. Then total rest time is equal to 20 minutes. Without stoppages is equal to 30 minutes. With stoppages is equal to 20 minutes. Therefore, total time is equal to without stoppages plus with stoppages is equal to answer. 30 plus 20 is equal to 50 minutes is equal to answer. Just general example, but depends upon speed condition. When speed is kilometer per hour, by using speed condition, calculate either speed of a either without stoppage time or with stoppage time. Therefore, total time is equal to with plus without is equal to answer. Here, first one answer option B. A second example important. Second example method. A goods train leaves a station at a certain time and at a fixed speed. After 6 hours, an express train leaves the same station and moves in the same direction at a uniform speed of 90 km per hour. This train catches up the goods train in 4 hours. Find the speed of the goods train is dash. Here A 50 km per hour, B 40 km per hour, C 36 km per hour, D 30 km per hour. Method. By using above information, one statement clearly given. That statement, here the express train catches up the goods train in 4 hours. Here we know that same direction catches up indicate both trains are covering equal distance. Therefore, distance is constant. When distance is constant, the relation between speed and time S1 T1 is equal to S2 T2. Where S1 speed of a goods train, you have to calculate S1. A T1 total time taken by goods train. But initially, the distance gap between goods train and express train time is equal to 6 hours. But second case, goods train travels another 4 hours. Total time taken by goods train is equal to 10 hours. And S2 is equal to 90. T2 is equal to 4 hours. Here S1 T1 is equal to S2 T2. Here find out S1. T1 is equal to 10. S2 is equal to 90. But T2 is equal to 4. Therefore, S1 is equal to 36 km per hour. Option C only correct answer. Right. Example number 3. A man is walking at 3/4 of the usual speed, reaches his office late by 2 hours. What is the usual time is dash. Here method. By using first statement, a man is walking at a speed of 3/4. Reaches his office late by 2 hours. Here reaches indicate in time, distance and speed. This topic, reaches term indicate distance is always constant. A distance between starting point and ending point. Here house to office, office to house, distance is always constant blindly. If reaches term, the term given, a distance is always constant. When distance is constant, the relation between speed and time S1 T1 is equal to S2 T2. Next, consider to the time. Late indicate plus operator. Here important only operator. This is applicable only time but not general method. Here consider to the time. Late is equal to plus operator and early denotes minus operator. This problem is based on only symbol notation, either using positive or negative. We know that in time condition, late is equal to plus, early is equal to minus. Next method, reaches means distance is always constant. S1 T1 is equal to S2 T2, but directly not given. Indirectly, reaches indicate S1 T1 is equal to S2 T2. Here S1 indicate, calculate S1 indicate usual speed. Then S2 is equal to 3 by 4 of the speed. 3 by 4 means S2 is equal to 3 by 4 into S. Next T1 indicate usual time is equal to T. And T2 is equal to late by 2 hours. Late means positive, means plus 2. In that equation, calculate only T. T is equal to usual time. Here method, S1 is equal to usual speed is equal to S. And T1 usual time is equal to T. S2 3 by 4 into speed, 3 by 4 into S. T2 late by 2 hours. Late means T plus 2. Just by using LHS and RHS, S term cancel, remaining 4T is equal to 3T plus 6. Then T is equal to 6 hours. Usual time is equal to 6 hours. Option B only right answer. Option B only right answer. Okay, third one. Next, fourth one, important. Fourth one, here one notation. Please just listen about time, distance and speed notation. If you read the problem, if two speeds are given, then check the direction. Same direction is equal to minus. Opposite direction is equal to plus. A same direction is equal to plus. Opposite direction is equal to minus. Here for a fourth example, meaning if the distance between two stations A and B is 120 kilometers, one train leaves station A towards station B at an average speed of 20 km per hour. After 1 hour, another train B leaves station B towards station A at an average speed of 30 km per hour. Find the distance from station A where the two trains will meet is dash. They calculate only distance up to meeting point. That is A distance is equal to answer. Here method, here A station towards B, B station towards A. Here notation 1. If two trains are moving in same direction, then relative speed is equal to minus. The same direction indicate negative symbol, and second, opposite direction indicate positive symbol. Same direction is equal to minus, opposite is equal to plus. Next, comment to the problem. Here first statement, total distance, here two stations A and B. Station A and station B, consider A and B. Here distance is equal to 120 kilometers. Distance 120 kilometers. Next one train, suppose consider train A towards train B at an average speed of 20 km per hour. Here A speed 20 km per hour and B speed 30 km per hour. These two are moving opposite direction. Your first method, here calculate first meeting point. Suppose I consider this point is called A and B meeting point. Suppose this is equal time, meeting point. Meeting time of two trains is equal this point. Next, suppose I consider let A time up to meeting point is equal to X hours. Then find out B time. Once again, let A time up to meeting point is equal to X hours. Then B time, above statement, after 1 hour, another train B leaves station B. That is the time gap between first train and second train is 1 hour. Here B takes 1 hour less than A time. Here A time up to meeting point is equal to X hours. Then B time remaining X minus 1 hours, but not X plus 1. After 1 hour, another train B leaves the station B. That means here B takes 1 hour less than A time, less than indicate x minus 1. Suppose A time is equal to x and B time is equal to x minus 1. Next method, here A distance up to meeting point, A distance up to meeting point plus B distance up to meeting point is equal to total distance. A total distance is equal to 120. By using above diagram, A distance up to meeting point, then B distance up to meeting point is equal to total distance. A total distance is equal to 120 kilometers. Next, to find out A distance. A distance is equal to speed into time. A distance means A speed into A time. Here A speed is equal to 20 km per hour. And next B speed is equal to 30 km per hour. Next A time is equal to x. Similarly B distance. Here B distance, B speed is equal to 30. B time x minus 1 is equal to 120. One equation, one unknown. Find out x value. This is equal to 50x is equal to 150. X is equal to 3. After 3 hours they will meet, but we want to meeting distance but not meeting time. Here find out meeting distance up to meeting distance. That means is equal to A distance. A distance is equal to 20 into x. A 20 into 3 is equal to 60. Option D only correct answer. A simple notations. This complete problem depends only time is equal to distance by speed. Distance by speed. In next, find out meeting point of two trains. That is x is equal to 3. Next, find the distance from station A where the two trains will meet. That is called A distance. A distance is equal to distance into time. Speed into time. Speed is equal to 20. Time is equal to 3. 20 into 3 is equal to 60. Suppose same information, calculate is equal to B time, where B time is equal to 30 into x minus 1 is equal to B time. 30 into x minus 1. Here 30 into x minus 1. 30 into 2 is equal to 60 kilometers. Otherwise, in general, a total distance is equal to 120. A distance up to meeting point is equal to 60. Then B distance remaining is equal to minus total 120 minus A distance. 120 minus 60 is equal to 60. Here, but we want only A distance up to meeting point, that is equal to 60. Option D only correct answer. Okay. Fourth one only option D. Right. Next, fifth example. Same as previous method. But fourth example, calculate distance, but here calculate meeting time. That is only one difference. Same logic. Yes, first statement information. Two stations A and B are 110 kilometers. One train starts from A at 7 a.m. and it travels towards B at 20 km per hour. Another train starts from B at 8 o'clock, 8 a.m. and travels towards A at a speed of 25 km per hour. At what time will the meet is dash? A simple method. A total distance A and B is equal to 110 meters, 110 kilometers. And next second statement, A speed is equal to 20 km per hour and B speed is equal to 25 km per hour. The same first diagram is important. This point is equal to A, next point B, A and B. A distance is equal to 110 meters. Next, suppose again same as previous example, this point consider meeting time of two trains. Suppose we consider meeting A time up to meeting point. Here A time up to meeting point is equal to x hours. Then B time up to meeting point. But A starting time is equal to 7 a.m. B starting time is equal to 8 a.m. Here B takes 1 hour less than A time. Once more, A starting time is equal to 7 a.m. and B starting time is equal to 8 a.m. The time gap between first train and second train is 1 hour. That is B takes 1 hour less than A time. Less than indicate x minus 1. Here A takes time up to meeting point is equal to x hours. Then B time is equal to x minus 1. In bracket B time 1 hour less than A time. The next same method. A distance up to meeting point plus B distance up to meeting point is equal to 110 meters. Same procedure, here A distance up to meeting point plus B distance up to meeting point is equal to total distance is equal to 110. A distance is equal to A speed into time. A speed is equal to 20 and A speed is equal to 20. A time is equal to x. B speed is equal to 25. B time is equal to x minus 1 is equal to 110. Now find out is equal to x value. Here 20 into x total 45x. Here 45x is equal to 135. X is equal to 3 hours. X is equal to 3 hours. But A starting time is equal to 7 a.m. B starting time is equal to 8 a.m. Suppose if you consider is equal to A meeting time 7 o'clock plus x hours. Suppose if we consider B 8 o'clock plus x minus 1 hours. Suppose we consider A means here A starting time is equal to 7 a.m. But meeting point A time up to meeting point is equal to x hours. Therefore 7 plus 3 is equal to 10. 10 a.m. Option B only correct answer. Simple method. This type of questions are very important to competitive exams. Here apply only logical approaching method. But here complete problem convert into a one equation. But here equation only x variable. By using above information calculate only x. X is called time. Here either problems in time, distance and speed. Find the meeting distance, find the meeting time. But here fourth example find the meeting distance and fifth example find the meeting time. But this question answer is equal to option B 10 a.m. is equal to right answer. Okay, right. Next. Your sixth example method. First information. A train runs at a speed of 42 meter per second. Takes 35 seconds to pass a platform. A platform is called stationary object. After traveling some distance, it takes 15 seconds to pass a pole. What is the length of the platform? Right, notation number 1. First notation number 1. First point information. A train crosses a single object. A train crosses a single object. Then distance is equal to length of the train. In bracket, single object means a man, comma, a pole, etc. Without distance is called single object. Next, second point number 2. A train crosses a stationary object. Then distance is equal to sum of two length objects. That is D is equal to LT plus LP, where LT length of the train and LP length of the platform. In bracket, stationary object means Stationary object means another train, a platform, etc. Another train, a platform, etc. The next sixth example method. First statement, a train crosses a platform. A train crosses a platform, then distance is equal to length of the train plus length of the platform. Your first statement, time is equal to 35 seconds, speed 42 meter per second. First statement, distance, length of the train plus length of the platform is equal to speed 42 meter per second into 35 is equal to 1440. This is equation number 1. A distance is equal to speed into time. We know that a train crosses a platform, then distance is equal to length of the train plus length of the platform is equal to speed is equal to 42, time 35 seconds is equal to 1440. Equation number 1. Second equation, same train. After traveling some distance, it takes 15 seconds to pass a pole. A pole is called single object. A train crosses a single object, then distance is equal to length of the train. By using same information, a distance is equal to speed into time. Second statement, to cross a pole, then distance is equal to length of the train. A length of the train is equal to speed 42 meter per second and time 15 seconds. 42 into 15, 42 into 15, 630, 1470, right? 630. This is equation number 2. Here first equation, LT plus LP is equal to 1470. Second statement, length of the train is equal to 630. Here calculate length of the platform. Then length of the train substitute in first equation. Therefore length of the platform is equal to 1470 minus 630 is equal to 840. Option C only right answer. Here sixth example method, using two conditions, stationary object and single object. And also important, a train crosses, if two trains are given, if two speeds are given, then check the direction. But sixth example, only one speed is given. No need to worry about speed condition. You worry about only distance condition. But when two speeds are given, then check the direction. A same direction indicate denominator S11 S2. Opposite direction, denominator is equal to S1 plus S2. Yeah, next, another point only important in time, distance and speed, that is conversion method. Conversion method is always depends on distance but not speed and time. Here conversion method is also important. Conversion method. Here conversion method using only distance condition. Suppose distance meter is given. Speed convert into a meter per second. Time convert into a seconds. Please once again. Here is time, distance and speed. Here basic level questions are using only conversion method. Here distance, time and speed. Conversions are always depends on distance. You check the problem. Just you read the problem. If you read the problem, if distance is meter is given, speed convert into meter per second, time convert into seconds. Suppose distance kilometer is given, speed convert into a kilometer per hour and time convert into a hour and point. Only two methods applicable in time, distance and speed, either meter per second or kilometer per hour. A general application, a meter per second convert into a kilometer per hour, it is multiplied by 18 by 5. A conversion method, meter per second, the term convert into a kilometer per hour, it is multiplied by only 18 by 5. Similarly, x kilometer per hour convert into meter per second multiplied by only 5 by 18 is equal to meter per second. These two only applicable in conversion method. A basic models in time, distance and speed, those are exist only conversion method. Complete problem you need to convert into one side. Either distance is equal to meter or kilometers. Speed conditions, meter per second convert into kilometer per hour, kilometer per hour convert into meter per second. This is about time, distance and speed method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.